3 over 2, comma 1/2. And that pattern matches up in all 4 quadrants. The only difference is obviously whether it's positive or negative depending on where, what quadrant and the coordinate point. You know, if your x or y is negative or positive. Then what happened is you went and you did the 45s. So we have the 45s right here. And again, they all have the same reference angle. And again, you should have noticed that they all have the same coordinate points, except negative or positive, again, where you're having to put it. And then finally, the last one is that you have reference angle of what? 60. And finally, those all matched up. So if you found one of them, you found 3 others, and actually once you found 30 right here, what do you know about the relationship between 30 and 60? Nick? They're reversed, right? Because this triangle in the red right here is the exact same triangle as the green, except it's just using a different angle, right? So their x and the y's are switched. So again, really once you know this, you should know the 60s, and then you should be able to fill it in. So let me kind of show you again. Well, actually, I'll come back to that. So that talks about kind of the coordinate points there. Now, some of you, I know fractions aren't really your strongest suit, okay? There are patterns, too, when you're converting to radians. When you go to convert to radians, first of all, at the 45 marks, you're adding a quarter, right? So there's 1/4. Here's 1/2, or 2/4. Here's 3/4, 4/4, 5/4, 6/4, 7/4. So you can go ahead and fill those in, and that kind of will give you a quick idea of where it lies. It's all adding a quarter, right? So you get all the way around, and then it's 8/4 to be 2 pi. That same sort of thing then happens when you go ahead and you do your 30s, right? You're constantly adding 30. And what's 30 degrees? It's just what? 1/6. So I go in, I get 1/6. This will be 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9. Wait. Yeah, 8/6, 9/6, 10/6, 11/6, and then finally back to 12/6. So it's just knowing those patterns instead of having to calculate it every single time. So when you eventually get to your unit circle, okay, and let's say that you want to fill this in, okay, I don't know if kind of keep track about how long it's going to take me. Let's say that this is 0 degrees, right? We'll do the degrees first because those are the easiest. That's 0, that's 30, 45, 60, 90, 120, 135, 150, 180, 210, 235.
Wait.
Thank you. 225. 240. 270. 300. 315. 330. Back to 360, right? Alright, now let's talk about the coordinate points. The coordinate points again, Jack?
So if I found like pi over 6 for the first one, what is it a measurement of?
What is the measurement of?
Yeah.
It's the measurement of the angle in radians. It also refers to the arc length in radians. Yep, Bryce?
What's the conversion to get to radians?
What's the conversion?
Yeah.
To get from degrees to radians or radians to degrees? Okay, what is it, guys? Probably?
Pi over 3.
pi over 180. And then 180 over pi to go the other way. Okay? So we have the angles all filled in, okay? Do you want to do the radians or do you want to do the coordinate points first? Coordinate points. Alright, now, even if you didn't remember this 30 degrees right here, right? Or that exactly what it is, you can quickly do the 30 degrees right here. And remember, your radius is always going to be 1. So what's the height? Half. What's the horizontal length?
Square root of 3 over 2.
Square root of 3 over 2. Now that should make sense because the height is shorter than the length, right? So when you go to do this, it's going to be half.
Okay, I'm upset that you didn't join the free throw contest,
Oh, I
and then
know.
they lost. If you would have been on the team,
I know.
Come
they
on.
probably could have pulled it off.
I didn't think they wanted me back.
Buttons.
Okay, so that's half square root of 3 over 2, right? What do we know about the 60? It's what? Well, actually, let's do this. So this one right here pairs up here, right? So that's half square root of 3 over 2, but what's negative? The half. Down here, I'm going to have half square root of 3 over 2. What's negative? Oh, down here, this is what? Half square root of 3 over 2, negative square root of 3, right? Now, I just filled that in without having to calculate each one because they all have the same reference. Let's go to the 60s. Square root of 3 over 2, 1/2. 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 This is positive, positive. This is negative, positive. These are both negatives. This is positive, negative. The last thing that you're going to have to do, one second, is you're going to have to fill in the 45.
Isn't that
Did I screw something up?
All of them are backwards. Yeah, all of it. 3 square root of 2s. Those are the X's.
Stretch it extra line.
One of the chances we got that right.
Ride surfboard on the class.
Okay, redoing this. If you don't screw up the first time, this is square root of 3 over 2, 1/2. This is square root of 3 over 2, 1/2. Square root of 3 over 2, 1/2. Square root of 3 over 2, 1/2. Alright, positive positives in this quadrant, right? This quadrant's negative positive, this one's negative negative. This one's positive negative. So, I go ahead, fill in the negatives. Okay, now I'm doing this right, correct? My brain is right now. Okay.
Trout.
Okay, and then finally the 45, 45. Those are easy, right? Because they're going to be the same. What are the coordinate? Square root of 2 over 2. So all that you have to do is go ahead and fill those in. Now, if you have a reference of 45, that should be the easiest. You should exactly know it's going to be square root of 2 over 2. And then you fill in your negatives appropriately. All right, coordinate points. Radius of 1. So this is going to be 1, 0. This will be negative 1, 0. 0, 1. And then 0, negative 1. Okay? When you go to do your radians, I'm just going to do the top half. Okay. So what do we know about 30 degrees? It's pi over what? 6. I add 1/3. It's going to be
Pi over
3.
5/3.
Okay, because it's 2/3. This is 3/3, which is 1/2.
Over 2.
This is 4/3.
4 pi over 3.
This is
Oh, no.
1, 2, 3, 4, 6, which is 2/3. 5, 6, and then 6, 6, which is pi. You can go back to the quarters. This is pi over 4. This is 2 pi over 4. This is 3 pi over 4. Okay? That took a lot longer than it normally does. But you guys get the idea of where the patterns are, right? Okay? It's by 6, by quarters, and you can see the patterns of the coordinate points. You'll want to know how to do those quickly. Okay? Now, why are those important? Well, because let's look at this 30 degrees over here. Okay? When I talk about 30 degrees, okay, and let's say that I'm talking about sine of 30 degrees. What is sine of 30 degrees? Opposite over hypotenuse, which is what?
1/2 over square.
1/2 over 1, which is what? 1/2. Let's talk about cosine of 30 degrees. What is that one going to be?
3 over 2.
Okay, adjacent over hypotenuse. So square root of 3 over 2 over 1. That gives you square root of 3 over 2. How does the sine and cosine relate? They're x and y's. Because your hypotenuse is always what? 1. So it's over 1. It's always going to be the opposite and then adjacent. So what's what? Sine of theta will always be what? Well, x or y? Y. That's important, guys. Sine is always going to be y. What's cosine going to then be?
X.
Cosine will always be x. Let's talk real quick about tangent. What's tangent? Opposite over adjacent. So it's 1/2 over square root of 3 over 2. Now, 1/2 is technically your what? Your y. And square root of 3 over 2 is your x. So tangent of theta is y over x.
Yeah.
So basically, if you're asked to find sine, cosine, tangent, cosecant, secant, or cotangent, you don't have to draw the triangle every time. You can refer to the unit circle, look at the coordinate point, and be able to pull out exactly where it is. Makes sense? We'll see a couple of these. All right, everyone has that down? Or need a minute?
Can you move down the word?
Yep.
What was that? What I heard over there?
What you saying about theta?
Theta is a good
Can we just take notes on this on our sheet?
You can put it on the sheet, you can put it somewhere else inside.
Oh, dude.
We're good?
Yeah.
We are super.
Super.
Super bad.
Alright. So here's your unit circle. We'll come back to that in just a minute. I want to quickly talk about just a refresher of reference angle. Okay, and we talked about this a couple days ago. I want to go over it. So reference angle is its distance back to what? That's 0. To the nearest what? X-axis. Nearest x-axis. So you need to know where 294 is. 294 is where? Quadrant 4. The closest is here, right? Oh, what happened?
That's a popular thing to say.
I don't know what happened. Alright. 294, right? It's in here. The
Yeah.
closest is the positive x. Now the positive x is either 0, but it's also what? 360. So I want to know this distance right here. So what do I do? 360, 294. What do you get?
66.
66 degrees. So the reference angle there is 66 degrees. Okay. 883.
Large.
How would you do this one? Subtract what? Subtract 720 because one rotation is what? 360. Two rotations is what? 720. So I go around once, that's 360. I go around twice, that's 720. And that brings me back to the start. So I'll do 883 minus 720, and that gives me 63. So then what I'm going to do is I'm going to go an extra 6.
Whoa.
You could have just added
160.
163, thank you. That's going to bring you to what? Quadrant 2. Where do I need to go now?
Negative x-axis.
To 180 right here, right?
17.
So I will do 180 minus 163, and you get 17 degrees. All right, questions? Let's talk about now that, go back to that unit circle. You need to find the 6th trig function for 135, okay? Now, how you do this without your unit circle? Well, you know 135 is a special angle, or special angle, right? It belongs to a unit circle. We know it's in the second quadrant. We know it has a reference of 45 degrees. I would know, because it's right in the middle, what's the coordinate point? Square root of 2 over 2. Square root of 2 over 2. What's negative, what's positive?
First one's negative.
X is negative, second one's positive. Alright? Again, because I know that reference angle right there is 45 degrees. And I should know that my 45 degrees are square roots of 2, square root of 2 over 2. So, if you didn't know that, for right now you have your unit circle, right? And here it is. 135, it's right there, right? So, when I want to know the 6 trig functions, I'm going to do sine of 135. I'm going to do all 6 of them. Cosine, tangent. What are the other 3?
Secant, cosecant.
Right, secant pairs up with cosine. What's the other word? Cosecant. And then the last one is? Tangent. Okay. Now, again, I don't have to technically draw the triangle for this. All I have to do is remember that my sine value is what? Is it the x or the y? It's the y. Now, so it's the y in this case. So again, make yourself a little note. It's the y. It's going to be square root of 2 over 2. Your cosine is what?
X.
X. It's going to be negative. Tangent is what? Y over x. I already heard some of you guys say it. It's not 1 though, it's what? Negative 1. Okay. Now, cotangent is just the reciprocal. What's the reciprocal of negative 1?
Negative 1.
Negative 1. What's the reciprocal? Which is what? 2 square root of 2 over 2, which is what?
Square root of 2.
Negative square root of 2. What do you think cosecant is going to be?
Square root of 2.
Square root of 2. Right. You don't have to draw it. You just x, y, y over x, and then you take the reciprocal. Question, Peter?
How did you get the cosecant?
Cosecant? It's the reciprocal again, but because these are the same, I just know that will be the same as that.
Oh,
Okay. So questions on that one? No, we're good? Alright, 780. Again, what would I know about 780?
Little more than 720.
It's what?
60 degrees.
It's really 60 degrees, right? Because they can subtract 720. So it's really 60 degrees. What's the coordinate point in that unit circle at 60 degrees?
1/2 radical 3/2.
Good. Okay. So, again? Oh, what happened?
Ah.
Johnson.
Sine 780. And you want to put the degree. It's the sine of that angle, okay? So don't put 60, it's 780. Okay, and it's not theta anymore because we actually have a specific angle. So let's do sine with sine.
Radical 3/2.
Square root of 3 over 2. Cosine, 780. 1/2. Tangent, over 1/2. What does that reduce to?
Square root of 3.
Square root of 3. Okay. Now we're doing the reciprocals, right? So we're going to get cosecant, 780. Alright, 1 second, I'll come back to that. Okay, this one is what? 2 over square root of 3. Someone already told me, I think.
2 squared 3/3.
There you go. It's just 2. And then this is 1 over square root of 3, which is square root of 3. Wow. Questions so far? Good? Let's go down to number 6. I'll come back to number 5 in just a minute. Alright, number 6. Find the 6 trig functions of 5 pi over 6. Now we just got to make sure that we're looking at the radians instead of degrees. It's going to be the exact same thing. I'm going to be looking for sine instead of an angle. It's in radians. Now, again, I think some of you guys are, at least in the past, what I've seen is that radians just throw everyone off about where it's going to be. But again, if you kind of remember the basics, it's 2 pi for a full rotation, right? So it's 1 pi here, pi over half, pi over, 3 pi over 2. Where was this going to lie? What quadrant?
2.
It's going to be in 2. And it's 5 pi over 6. It's pretty close to here. So it's going to have a reference to what?
150.
30.
Well, it's 150, right? It's the same as 150. So what's the coordinate point going to be?
Negative square root of 3/2, 1/2.
Good.
Comma, 1/2.
It's closest. It has that longer x. Probably.
You converted by 180 over pi, right?
Yes. To go to degrees. Yeah. But again, next year I know, especially Morel and Piper, they're not going to want you to want to convert every time. They're going to want you to know just 5 pi over 6 where it's at without having to convert it. Okay. So sine is going to be what?
1/2.
1/2. Cosine.
Negative 3/2.
Okay. Tangent.
Negative
Okay. Now Now this one's going to be a little bit longer because it's going to be 1 over negative square root of 3, which is negative square root of 3 over 3. Cosecant is going to be the opposite. That's going to be 2. This will be
2 square root of 3 over 3.
Negative.
negative, and then cosecant will just be negative square root of 3. Most of your homework is not going to be asking you to do all 6 of them. It's just going to say find secant 5 pi over 6. Find tangent 5 pi over 6. They're going to be just kind of be one step problems. Is that clock really off now?
No, your clock sucks.
My clock's off?
PM. Why don't we check my phone?
Yeah, yours says 10:56.
It's a little off. And this is not the 16th, is it? Okay.
Stop poking myself.
No.
So there's gonna be a couple questions that just ask you to evaluate, okay? So you do each one individually, and then you do the operation. So again, you guys can refer to your unit circle. What is sine of 45? What is it? Okay, so it's just square root 2 because we just want sine, right? So it's square root of 2 over 2. Now this one, it's asking us to do a couple things. It's asking us to times it by 3 and to square it. So what is cosine of 135? Negative.
It used to be negative square root of 2 over 2.
Okay, because it's 45 reference, right? And then finally 225. Reference of what?
That one's going on YouTube.
Who was that?
Then you're going to evaluate. Square root of 2 over 2 plus 3 times negative 2 over 4 minus, those 2's will just cancel out, so it'll make plus square root of 2.
Don't talk in class.
Square root of 2 over 2 plus negative 6 over 4. Oh, I did, yeah, you're right, I didn't do. Back up, guys. You're right, I was thinking sine. Square root 2 over 2. No, square root 2 over 2. That's just what? This negative 1 will be minus 2 right there. The double negatives, yeah, I can't. The negative was already there.
No, but on the other side. So it's plus 3.
Yeah, you're
Gotta
right.
be so critical.
Guys in the middle. Square root 2 over 2 plus 6 over 4 minus 2. Adding fractions, you need a what? You need a what?
Denominator.
Denominator. What's the denominator?
4.
4. So 2 square root of 2 over 4 plus 6 over 4 minus.
Why is it 4 when those are both divisible by 2?
6, isn't it?
You're right, yes.
It's 4 because it said so.
True.
Because my brain is over.
She's the teacher, so you
2 square root of 2 over 4. Negative 2. That reduces. Maybe longer than I wanted to. Square root of 2 minus 1 over 2. And there's your final answer. That's what evaluates to. Okay? That's just working with the fractions and radicals.